In this video, we're given just a couple reminders about basic derivative rules. The first box is the power rule. If I have x to the n and I differentiate it, I bring down the exponent out in front and subtract 1 from the original exponent. The second one is saying that derivatives respect linear combinations. So I have a linear combination of two functions. That's a sum of constant multiples of these two functions. And the derivative sees right past those constant multiples. So I end up with that a that was originally in front of the f times f prime. And I end up with the b that was originally in front of g times g prime. So that's how a derivative works across a linear combination. These two rules together allow us to differentiate polynomials. So in our example, I have negative x squared minus 2x plus 5. I want to differentiate this thing. So when we differentiate f, the derivative sees past all the coefficients of these powers of x. And by the way, I could write an x to the 0 in here if I like and use the power rule on that. So I have negative x squared prime minus 2x prime plus 5x to the 0 prime. And I'm going to go ahead and call that x to the first where the x is, just so I can really show how the power rule is working here. So after applying the linear combination rule, all the things I have to differentiate are just simple power functions of x, and I use the power rule on those. So I have a minus sign out in front of this first one, bring down the exponent, subtract 1 from it. And the second one, I bring down the exponent, that's just a 1. And I end up with an x to the 0 when I subtract from that exponent. And then the third one, I have 5 times 0, x to the negative 1. Or you could just remember the derivative of a constant is 0. Either way, that 0 kills that term. And I end up with negative 2x minus 2 because x to the 0 is 1. To finish the problem, we were asked this time to find f prime evaluated at x equals 2. So I have to plug in x equals 2. And I get f prime of 2 is negative 2 times 2 minus 2. And that's negative 4 minus 2 or negative 6. And we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.